Okay, so today we're covering angles using the unit circle and radian measure. So the first thing that we should know that we have this. We have standard, position of angles, and for the standard position, the initial side is always horizontal and pointing to the right, and then the terminal side is where that angle ends, vertex. And then this here I will call theta. In this case, since we're going counterclockwise from our initial to our terminal side, we have a positive theta value. Another case, when we're still in a standard position, we have the initial side here. And then the terminal side if we're opening down, if we're opening in the clockwise rotation, this theta value is going to be negative. So we have a negative theta. It's important to notice that here, this angle technically has two measurements. It has this measurement going following my navy blue, which is going in counterclockwise direction, or the angle that's going in clockwise direction. Similarly, this angle here, we have the counterclockwise direction. It's a negative value. And we also have the positive, the counterclockwise direction. Okay, but that's just standard position. Any questions on that? Okay. Next, I just want to explain what a radian is. You know, we're going to be talking a lot about moving from degree to radian form. So it's important to know what a radian is and to be able to kind of visualize it. So if I have a circle, and I'm going to put an axis on the inside of it. Okay, pretend that's centered. Some important values to know is that this here is 0, radian 0. This is pi over 2 radians, or 90 degrees. This is pi radians, or 180 degrees. This is 3 pi over 2 radians, or 270 degrees. And then this is also called 2 pi. But a radian, so a radian is, we determine the radian based on arc measure, arc length. So right here, about almost a third of the way through, this arc length is equal to 1. And where the arc length is equal to 1 means that we have 1 radian. Okay. Similarly, if we have something right around here, this arc length here is equal to 2, and this angle is 2 radians. Okay, notice that this is about 1/3 from 0 to pi, this first radian. The second radian is about 2/3 of the way. So that's where the number pi comes from, right? Pi is 3.1415, whatever. So this value here is the arc length. Arc length equal to 3.1415, blah, blah, blah. Which means that the radian measurement is pi radians. Does that make sense? So that's where pi comes from, but that's also kind of what a radian is, so how we can visualize a radian. Another important thing to note is that we could have negative radians. So about here, this arc length is still equal to 1. But since we're moving in the clockwise position, it's minus 1 radian. Okay, any questions there? Okay, the next thing that we have to know is the conversion formulas. So to go from degrees to radians, 1 degree is equal to that value, the degree, times pi over 180, and that equals your radians. To go from radians to degree, we have radians is equal to that radian measure times 180 divided by pi, and then it's in degrees. Okay, any question there? A way you can remember this is radians usually are associated with a pi value, right? Like 2 pi, pi over 2 is in radian measure, pi, 3 pi over 2 is in radian measure. So when we want to go to degrees, we want to cancel out that pi, so that's why we divide by pi. Similarly, if we have degrees and we want to get to radians, we have to go ahead and multiply that pi in. And that's just how I've always kind of remembered which way goes where. Any questions? Okay. Moving on to the actual worksheet then. You don't need to take a picture of those notes. Those are just for you to have, so you don't have to worry about submitting those. Problem 1, part A. Problem 1, convert the following angles from degrees to radians. Give both exact answers and when appropriate, approximate to 3 decimal places. Also identify which quadrant each angle lies in. So we have 27 degrees. And that's equal to, if I multiply 27 times pi over 180, that ends up equaling 0.15 pi radians. And you could do RAD for, so you don't have to keep writing out radians. Okay, so now these two angles, 0.15 pi radians and 27 degrees are exactly the same. If you were to draw them both out, they would overlap and they'd look exactly the same. So in this case, it's easier for me to look at, I can't really visualize where or do that multiplication of 0.15 times pi in my head to know how big that number is. And then I'd have to determine if it's, then we have to determine if it's which quadrant it's in. So we have to determine which of these values it's in between. So that would be hard in this case with the radians. But 27 degrees I know is in the first quadrant. So Q1 is the answer there.
Just a quick question.
Mm-hmm.
Is it okay if we didn't leave it in pi form and we solved it completely for radians? So for like the first one, I got 0.471, which would be the same thing as 0.15 pi.
I would prefer you keep the pi there unless it asks for approximations, which this one does. So what we should actually have both. But in general, I prefer just keep the pi, keep it a nice number.
Okay.
I don't understand how you get it in that form. Like if you're actually multiplying it by pi over 180.
Of course, it's not here. Okay. So if we have 27 times pi, your shift caret will give you the pi symbol, divided by 180, it's 0.471. Does that make sense, Faith?
No, yeah, I understand how to do that, but I don't understand how you got 0.15.
Okay, so since it's just, this is the same as 27 pi divided by 180. So I kind of treated pi kind of just as, I guess as a number, but I just didn't multiply it. So I just did 27 divided by 180. And that's 0.15, and then it's still being multiplied by pi.
Oh, okay.
Okay, so this was about equal to 0.4, I already forgot that number. 71. Any questions there? Any other questions? Okay, for part B, we have negative 10. Negative 10 degrees is equal to negative 10 degrees times pi over 180, which is equal to negative 1 over 18 pi radians. Okay, negative 10 degrees means that we have an angle and it's opening down this way, and it's only going 10 degrees, so we are in quadrant 4. And then you could plug this into your calculator and someone let me know what it's about equal to.
Wait, so why is it in quadrant 4 again? Sorry.
So it's in quadrant 4 because if I were to put it on an axis, I have my initial side on my positive x-axis, and it's negative 10 degrees. So it's going clockwise 10 degrees, which puts us in quadrant 4. So the
Okay,
positive negative just tells us which way we're rotating, and then you choose the number for the degree measurement. Did someone plug this in your calculator and can you tell me what it's about equal to 3 decimal places? Okay, so it's negative 1 divided by 18 divided by 18, and then multiply that by pi. into 3 decimal points, that is about equal to negative 0.175. Any questions there? Okay, moving on to C. C, our degree is 600 degrees. That's equal to 600 times pi over 180, which 600 divided by 180 is 10 over 3 times pi radians. I'm going to let you guys plug that in to get the approximate form and let me know what it is.
I got 10.472.
10.472 radians. Cool. Okay. Now we have to figure out which quadrant this is in. So we could do this one of two ways. We could either deal with the radians or the degrees. Since it's over 360 degrees and it's over 2 pi, we have to kind of get it in the range of 0 to 360 for the degrees or 0 to 2 pi for the radians. So I will take 600 minus 360, right? So what's happening here is, well, yeah, the angle 600, if I draw a circle again. Oops. The angle 600, I know is about here. But when it's 600 degrees, we start here and we go around one whole time and this extra. Okay, so we could kind of keep circling around, and if we keep adding 360, we'll get higher and higher degree numbers, but it will show the same angle. Okay, same thing with radians. This is about 10 over 3 pi radians as well. So if we start here and we go around to 2 pi and then around this angle more, we're left with 10 over 3 pi radians. So if I subtract 360 from 600, I'm left with 240. And remember those 4 important numbers I told you, these green ones here. 240 is between 180 and 270. So that means that this is in the 3rd quadrant. So we're in quadrant 3. Okay. You could also do it with the radian measures. If we have 10 divided by 3 pi, if I subtract 2 pi from this, you end up with 4 over 3 pi. 4 over 3 pi is between pi and 3 over 2 pi. So it's in here. So we're in quadrant 2. Any questions there? Okay, part D, we have the angle negative 562 degrees is equal to negative 562 times pi over 180, which this ends up equaling negative 562 divided by 180 is 280, negative 281 divided by 90 pi radians. Okay. So we have to figure out the quadrant. And you guys can plug that into your calculator and let me know what the approximate value is.
I got negative 9.809.
Negative 9.809 radians. Cool. Okay, next we have to figure out the quadrant. So if we're at the angle negative 562, instead of subtracting 360, right, the goal is to get between 0 and 360. So instead of subtracting 360, I'm going to add 360 every time. So essentially what's happening in this one, erase this circle. What's happening in this one? Okay, so we're starting here, but we're moving in the negative direction. So we're going around at least once, and then we're going around this leftover amount. Okay, so we want to get it between 0 and negative 360. Once it's between there, we'll know the negative, we'll know this chunk here. And since it's negative, we'll just work backwards and figure out where that degree is. So if I do negative 562 plus 360, I get negative 202 degrees.
So would that be quadrant 2?
Yes, that would be quadrant 2. And the reason being, because since we're going negative, here to here is from 0 to negative 90. Here to here is negative 90 to negative 180. Here to here is negative 180 to negative 270 to negative 270. Here is negative 270 to negative 360. Another thing that you can do, if the negatives and flipping it around kind of confuses you, you can certainly subtract or add 360 again, and then you'd end up with 158. And 158 is between 90 and 180, so we're still in quadrant 2. So whatever way works best for you. Any questions there? Okay. Problem 2. Convert the following angles from radians to degrees. Give both exact answers. When appropriate, approximate to 3 decimal places. Also identify which quadrant each angle lies in. So now we're going from radians to degrees. So we have pi over 18 radians is equal to pi over 18 times 180 divided by pi. Oops, not 10. Pi. Pi's cancel out. 180 divided by 18 is just 10. So 10 degrees. And 10 degrees is in which quadrant?
The first.
Good. So this is in Q1. For B, we have negative pi over 10 radians, and that's equal to negative pi over 10 times 180 over pi. The pi's divide out to 1, so we're left with negative 18 degrees. Where will negative 18 degrees lie? Which quadrant?
The fourth.
Good. Any questions there? Okay, next we have 8 radians is equal to 8 times 180 over pi. Radians don't have to have a pi in them. It's most common for them to, but they don't have to. Remember, 1 radian is just where the arc on the unit circle is equal to 1. So 8 times 180 over pi, and this gives us 1440 over pi degrees, which is about equal to 458.366 degrees. Any questions on just that conversion first, before we get into the quadrant? Okay. And to figure out which quadrant it's in this case probably easier to work. Actually, I don't know if this is true, but if we work with the degrees, we have 458.366 degrees. We're going to go ahead and subtract 360 degrees, and that gives us 98.366 degrees. So which quadrant are we in?
The second?
Good, we're in Q2. Any questions there? All right, next we have 6 pi over 5 radians, which is equal to 6 pi over 5 times 180 over pi. The pi's divide out to 1, so we have 6 times 180 divided by 5 is 200. Is 216 degrees. Okay, and in 216 degrees is in which quadrant?
Three.
Any questions on that material? Okay. Problem 3. Now we're talking about arc length. So what is the arc length spanned by the angle 3 pi over 4 radians on the circle of radius with radius 4 inches? So another important formula for you to know is arc length. And it's given by the variable s. So s is equal to p times r, where p is the radians and r is the radius. So in this case, our p is 3 pi over 4 and our radius is 4. So s is equal to 3 pi over 4 times 4, which is just equal to 3 pi unit inches.
Could you just move the screen down a little bit? Thank you.
Yeah. Any questions there? Okay, next is problem 4. What is the arc length spanned by the angle 300 degrees on the circle of radius 2 centimeters? So for P, P is our radians, so it's 300 degrees, but we have to convert it to radians. So 300 degrees times To convert to radians, we multiply it by pi over 180, which is going to be 5 over 3 pi. So P is equal to 5 over 3 pi. And our radius is 2 centimeters. So we have that S is equal to 5 over 3 pi times 2, which is 10 over 3 pi, which is about equal to 10.47197 centimeters. Any question there? If you have no questions, you are free to go. Have a great rest of your day. I will see you on Friday. Try to get outside. It's really nice out. I was out this morning. If you do
Thank you.
questions, I'll stick around.